We're about to solve a really crazy looking limit problem below, and it might seem intimidating at first, but it doesn't have to be if you know these two awesome tricks. Let's get started. We have the limit as x approaches infinity of e to the x squared all over e to the x squared. Notice how the denominator seems to be growing rapidly faster than the numerator. That's giving a hint already at what the answer might be. What do you think it is? Leave a comment below and also share how you would approach solving this problem. The very first thing I like to do when I see a problem like this is I see that there are some patterns in place. We've got a repetition of e to the x squared both on the top and bottom. My approach here is that I'm going to do what's called a u substitution. And if you haven't seen this before, no worries. I've got a video on the screen that you can look at in case you want a refresher. So we're going to let u equal e to the x squared. In other words, everywhere you see e to the x squared, you're going to substitute in u instead. Also notice that when the right-hand side of that equation, e to the x squared, approaches infinity, on the left-hand side, u will do the same. This allows us to rewrite the problem as the limit as u approaches infinity of u over e to the u. It looks simpler already, doesn't it? And before I go on, if you haven't already, hit that subscribe and like button and turn on that bell notification so you don't miss my future videos. Now you might be wondering, okay, well, the answer still looks like it's obvious here, but how do I take this further and show the proof of my work? Well, what you can do is simply plug in infinity on the top and bottom and notice how the fraction will approach infinity divided by infinity as u approaches infinity. This results in something known as an indeterminate equation. And for a case like this, we can apply this really cool trick called L'Hopital's rule. And I've made another video on this as well if you haven't seen it yet. What this simply says is that for an indeterminate case, when you have u over e to the u, you can rewrite this in a way where you can take the derivative of the top and the bottom and then solve that new equation. So we'll have the limit as u approaches infinity of the derivative of u with respect to u, which is 1, over the derivative of e to the u, and that's just simply e to the u. Check this out. The final equation is just 1 over e to the u, and that's an obvious answer. When you take u to infinity, the denominator just grows exponentially, and we're left with a final answer of 0. So I hope you enjoyed this video, and if you haven't already, be sure to check out this playlist that you see here, and I'll catch you later.